we can actually change the execution order of the globals. So if I actually turn these back on, and now if I do a render, you can see these are both set to render geometry, and you can see this is also set to render geometry. And if I do a render, you can see that actually this one isn't set to render geometry, this one's set to render none. So I'll very quickly put that to render geometry. And now if I do a render, you can see that although this is set to bounding box, these two are overriding it. And that is because if you go to the options, action order, you can see it's applying the local operators first. And that means that these then get control of the particles. If we change the action order to globals first, and now if we do a render, you can see that the global will actually take over control of the particles. So, and an interesting thing that I noted earlier is that if you, as an example, we've got the bounding boxes working here. You can see I've got geometry here. But if I change the order back so these have control, just change that back. And now if I do a render, you can see it's now using these values. An interesting thing is if you set one of them to use to put nothing to the renderer, and do a render, you see that you've actually got bounding boxes. So although this, you would expect this to actually have control and to send nothing to the renderer, because it's actually putting nothing to the renderer, the global render operator is then allowed to actually assign its value. So it's not actually overridden. Because this actually puts nothing into it, this can then actually assign a value to it, and that then gets passed on to the renderer. So you should find the same thing here. If I set this to none, now instead of getting nothing, I should actually get the values from this coming through. So there you go, we've actually got bounding boxes in there. So let's have a quick look at the rest of the options in this operator. The next parameter we have is visible. And that's a very basic multiplier value again. It can't go above 100%, but it can actually go down, obviously down to 0. So if we set our display type back to geometry, do a quick render, there we have 100%, but you can very quickly put that down to 50%, 10%, whatever it is that you want to render, and only get that at render time. And obviously if we've got these set up, if I just turn this off and set these to geometry again, there we go, do a quick render, that's looking cool. Let's say we just wanted to change the what's been rendered from this event. Obviously because we've got just this render operator in this event, we can actually just go in and just have 10% of the particles in this event rendered. So if I do a render now, you can see we've actually taken out all the particles from here. Obviously at render time that would look a little bit strange because you'd only have 10% of the particles being rendered in this event, and when they get past the next event, obviously 100% of the particles would suddenly be rendered, and effectively 90% of your particles would pop out of nowhere. So obviously that's something to be aware of. The next option we have is the render result, and that's basically defining how the meshes are actually passed the renderer. Now the first option and the default option is single mesh, and what particle flow does is at render time, when it passes the particles to the renderer, it gets all of the meshes in the particle flow and it just joins them all together into one big mesh, and it hands that on to the renderer. Now there are limitations with that. For instance, I was talking about earlier in the shape instance operator that when you actually get your particles passed onto the render engine, they're not true instances, and you can actually see this is pretty obvious here because they all get joined into one single mesh. So you can see the second option is multiple meshes, and with this option, what particle flow actually does is it sends your particles to your renderer in groups. And this is useful for render systems that are having issues with rendering, you know, one large mesh. You know, certain renderers may actually choke on that single massive mesh. The two parameters which are associated with it are the mesh count, and if I turn it on, you can see you've got the mesh count here, and this is the maximum number of particle groups that particle flow can actually send to your renderer. And then you have a particles per mesh option, and what that does is this parameter defines how many particles should ideally be assigned to each group. So these two parameters are used together to work out the optimum number of particle groups that are passed to your render engine. The final option is to pass one mesh to your render engine for every particle, and although this may possibly be the best option for your renderer, this is actually the slowest of the three options for particle flow, as far as I understand it, in terms of actually translating your meshes into something that the renderer can use. As I said, it passes an individual mesh onto your renderer for each particle, and because of that, it can be very slow to generate your particles. But as I said, you know, it can be useful for some render engines. So those are the options. You'll obviously have to try out the render result options with whatever render engine that you're working with. If you're having trouble rendering your particles, try using the other options, multiple meshes or one mesh per particle, and you may actually find that they render a little bit more successfully with whatever render engine that you're using. Okay, that's it for the render operator. Let's move on now to have a look at the script operator.